This is the 10.3 homework, number 1 and number 2. Okay, so for number 1, looking at the equation, and since the general equation is y equals 1 over x, then here, since 2 is being added, we know y equals 1 over x is shifted 2 to the left. And since there's a plus 1 here, it's also being shifted 1 up. So then our center point was at 0, 0. Now we'll go 1, 2 to the left and 1 up. So our new asymptotes are right here, intersecting at that point we found. And now at the starting point, it looks like y equals 1 over x has a point at 1, 1. So we'll move that point over, 2 to the left and 1 up. And then we will make our curve. And there was a point at -1, -1, and that will also go 2 to the left and 1 up. And we'll connect. So there's our graph. Our domain, it looks like x exists or the function exists everywhere except for at x equals -2. So our domain is -infinity to -2 union, because -2 itself doesn't exist, or rather the function doesn't exist there, -2 to infinity. And then the range, it exists everywhere except for y equals 1. So the range is -infinity to 1 union 1 to infinity. Our vertical asymptote, we already found. It was here at x equals -2. And our horizontal asymptote, which was right here, was at y, oops, kept at the rainbow, oh well, y equals 1. For number 2, we're looking for the equation. So typically, y equals 1 over x is centered at 0, 0. It looks like the center of this equation that's graphed, there's an asymptote, and there's an asymptote. So the center is right here at 1, 2. So then the graph was moved 1 to the right and up 2 to get from this point 0, 0 to this point 1, 2. Again, 1 to the right and 1 up, or 2 up. So 1 right, 2 up. So if we start with y equals 1 over x, now we have y equals 1 to the right will be 1 over x minus 1. And then up 2 will be plus 2. So there is our equation.